Somebody read, please.
A light bulb emitting 100 watts of radiant power is positioned 2 meters from the surface. The surface is oriented perpendicular to a line from the bulb to the surface. Calculate the irradiance at the surface. If all 100 watts is emitted from the red bulb at 650 nanometers, calculate the luminance at the surface.
It is what kind of a bulb? It's a red bulb. So I'm going to change my bulb to red. How far is it?
2 meters from the surface.
And this is 2 meters from my surface. I have to find the illuminance, EV, at the surface. At the surface. So they give me how much the light bulb is giving out. So I can find what's the relationship between illuminance and what's the closest term you can find in this formula for illuminance?
What?
So illuminance is a photometric unit.
Yeah.
What's the equivalent radiometric unit?
Irradiance.
Irradiance, right?
Yes.
So if the light bulb is the one that's emitting, I can find the irradiance of it anywhere. So I can find irradiance by using the formula for irradiance, which was E equals delta phi E divided by delta A. Yes? So this is the area of the source. So this will be phi E that the source is emitting divided by 4 pi r squared. So this would be 100 watts that illuminates an area 2 meters away.
1.989.
1.9 watts per meter squared. Okay, now how do I go from my radiometric unit to my photometric unit? This is where that's going to come in handy, that formula. I have my radiometric unit, and I also know that all I have to do is figure out where my irradiance lies and figure out what my V lambda is. So I'll show you how to do that. So from my CIE curve, lambda that is given is 650 nanometers. Okay, now I'm going to go up to my curve. Where is 650 nanometers? It is in between red and orange. I'm going to make it thick. So 650 is about here. Work your way upwards until you hit the curve. Okay? Work your way outwards until you hit this part. Okay, so this implies your V lambda is 0.1. So once I have that figured out, I can go from my photometric unit to my radiometric unit using this formula. So what is my photometric unit? Photometric unit equals K lambda times radiometric unit. Or what was it? 685. 685 times V of lambda times the radiometric unit. So this was in general. What is it now for me? I need to find illuminance, which is equals to 685 V as a function of lambda times my irradiance. And illuminance was what? EV. So then I can write 685 times 0.1 times what was the value for irradiance? 1.9 watts per meter squared.
130.15.
130 what?
0.15. Oh. Oh.
And that's how you do these problems. So for example, next time a question might ask you for exitance. So you could do the same thing. Just remember, this is the important part. Come up here, figure out what your lambda is and what your V lambda correspondingly will be. Good?
Yes.